Hi everyone, my name is Michael Kennedy from the University of Virginia. I'm the producer of the HLP and Special Education video series. On behalf of the entire HLP and Special Education video production team, I'm pleased to introduce this new series featuring unedited clips of teachers of students with disabilities implementing various HLPs and evidence-based practices. The teacher and students featured in this video are not actors. The teacher is a certified professional and was recruited following a nomination process from her district. Parents of all children signed consent forms. Some students who are not identified have IEPs. The teachers were not given any script, but they were asked to demonstrate certain HLPs. Viewer opinion on various aspects of the lesson will vary. This video, in its unedited form, is intended to spur dialogue amongst professionals and those in training around options for implementing high-quality practice. All comments and discussion in that vein should be respectful and honor the willingness of the teacher and students to put themselves in this vulnerable position to benefit your learning.
Today in whole group we discussed how multiplication is a shortcut for repeated addition, right? Yeah. And this week we're focusing on our multiples of 3 and 6. Thinking back to our last unit, what are some ways we can represent multiplication using models? Raise your hand and give me an idea. Marco?
Array.
An array. Awesome. Devin?
Equal groups.
Perfect. Ariana?
Repeated addition.
Repeated addition. Give any others? What about on a number line?
Number line.
Awesome. Okay, and today our focus is going to be on equal groups and number lines. One thing I want you to remember about multiplication is that you have to read the number sentence how it's written. So for instance, this reads 3 times 6. Do you remember what that X stands for? Go ahead.
Groups or jumps.
So for a number line, we'd have jumps of. For our groups, it would be 3 groups of 6. Now, what is the property called when you switch those two numbers around? Commutative property. The thing we need to remember is that 3 groups of 6 is going to look different than 6 groups of 3. Right? So 6 groups of 3. Alright, so same product, correct? The commutative property tells us that no matter the order of our factors, the answer or the product stays the same. However, it looks different. So we have to remember that that X is a shortcut for groups of or jumps of. And we have to remember to put, because if it's a commutative property, you're going to use a completely different model for that, okay? Okay, so what we're going to do now is I'm going to give you 2 cards. You'll have one that's a correct example that shows the correct number sentence with the correct model. You'll have one that's a non-example, meaning that it's not correct. So I'm going to give you 2 cards. I want you to take a minute, look at the number sentence, look at the model, and tell me if it fits, okay? So here's 2. And when you think you know which side it goes on, go ahead and place it there.
Can it be with a commutative property?
No, so I want it to be just how that sentence reads. The commutative property you're going to put on a non-example because it's going to be a completely different example, okay? Good question. Okay, who had 3 times 5? Okay, so you said this is a correct example. Read this sentence using words, please.
3 jumps of 5.
Great, and we have 3 jumps that are 5 long. Great, that is an awesome example of 3 times 5. Who had 3 times 11? Okay? Tell me what.
3 jumps of 11.
Okay, so you have an 11 long. And sometimes we won't know the factors, like we don't maybe know how to count by 11s yet because we actually haven't studied that yet. So you can do those little jumps underneath, right? So this is 3 jumps of 11. We have 3 times 10. All right, do we agree that this is 3 jumps of 10?
Yeah.
3 times 10. And do we agree that this is 3 jumps too long? Great. Okay, so then I sort of tricked you a bit by putting the commutative property in there. It's not that we can't use the commutative property, is that the commutative property makes it a completely different model because 3 groups of 5 is different than 5 groups of 3. So we have 3 times 5, and this one actually did 5 jumps of 3, so that's correct. 10 jumps of 3, so that's non-example. 2 jumps of 3, non-example, and 11 jumps of 3, non-example. Good. Okay, nice job. You guys are doing great. All right, I'm going to show you an example of our next activity. What we're going to be doing is I've provided a number line and a space for your equal groups, and there are some popsicle sticks. So I'm going to show you an example. What I'll do is I'll grab out a popsicle stick and it says 3 times 9. So on my, it says number sentence. I'll write 3 times 9. How can I write that in words if I'm doing a number line? Devin?
3 jumps of 9.
3 jumps of 9. So I'm just going to write it out real quickly on my board. I know my first jump is from 0 to 9, right?
Yeah.
But maybe I don't remember what the next multiple is going to be, so I can count underneath. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 18. And then I do happen to know the next one is 27. And so it shows, the model correctly shows that 3 times 7 is 29. I'll repeat this down below. And I'm going to say 3 times 9. How am I going to write this in words, Parker?
3 jumps of 9.
I'm going to do equal groups.
3 groups of 9.
There you go, 3 groups of 9. And then I'm going to draw my 3 groups, and how many are going to go in each?
9.
9, correct. All right, are we ready?
Yes.
Okay. Go. All right, Parker, you can grab one. Good. So seeing all jumps of, awesome. You're in jumps for number line. That's wonderful. You guys are doing a really nice job. Not only are you focused and quietly working, you're doing a nice job with showing your work underneath if you're not sure of the multiple, using nice handwriting, and quickly moving from one to the next. I'm really proud of you for staying so engaged and working so hard.
Is this the commutative property?
So 3 times 8. Oh, no, sir. No, you're going to do equal groups down there.
Oops.
Good question. Okay. 3 groups of 8. Jumps. Great. What was your product?
26.
What was your product?
23.
24. 3 jumps of 8. So when you did your 3 jumps of 8, what did you land on?
24.
Great. What about you, Marco? What was your product?
30.
30. And you had 30 dots in your groups? All right. What about 36. So 3 times 12 is 6. And 3 times 7 is
12.
3 times, oh, hold on. Oh, you have your number backwards. 21. Right? Close it right there. All right. So now what I want you to think about is, we talked about the commutative property. And remind me what the commutative property says again, Marco?
No matter the order, the product stays the same.
Great. So no matter the order of these factors, the product stays the same. But what do we know about the commutative property in models? Are they the same or completely different?
They're completely different.
Completely different. So let's do, for the next step, since you all are really great at representing the multiplication through your models, what I'd like you to see you do is have you do the commutative property. So now, instead of doing 3 times 10, you're going to have 10 times 3. Which, how does that translate? It would be 10
times 3.
But it would be 10 jumps of 3 and 10 groups of 3. Awesome. So I'm going to give everybody a new stick. You can grab a new stick, and instead of doing the one that's actually on your stick, I want you to do the commutative property. Everybody have a new one? That's okay, pick a different one. Okay.
So this would be 12 times 3.
Absolutely. Yep. what is your sentence say?
Oops.
That's okay, fix that real quick. 3 groups of 3. Perfect. You're going to take another stick. Go ahead and do the one that's on the stick, and then if you finish, you can do
Is
commutative.
12 times 3 the 36?
You got it. Isn't that cool? You can figure out, see, we haven't learned our multiplication tables for 3s or 12s yet, and that's awesome that you're able to use the model to represent the product. That's wonderful. Okay, let's look at yours together. So, read this number sentence for me.
3 times 4.
And what does it say in words?
3 jumps of 4.
3 jumps of 4. So let's look closely. How many jumps do you have just looking at this? 1,
4.
2, 3, 4. What does your in words say?
3 jumps of 4.
Okay, so what do we need to do to correct that?
Do 3 under.
And how long should each jump be?
3 under.
So 3 jumps, 4 long. Let me show you how I would think of that problem. Can you look at my board? I'm going to show you what I would do for 3 times 5. If you're finished, you may pick another. Those both look great. Pick another one and solve on your board, please. So then I would think of this as 3 jumps of 5. And then the good thing about thinking about it is words, because I know how many jumps am I doing?
5.
How many? But 3 jumps of 5. So how many jumps?
3.
3 jumps, right? So I'm going to go 5 underneath. So 1, 2, 3, 4, 5. Here's my first jump. 1, 2, 3, 4, 5. Second. And 1, 2, 3, 4, 5. Here's my third jump. So do I have 3 jumps that are 5 long? Yes. So that's why we think of this X. If you think about it in words, it represents jumps of. Another way to think of that, how it's represented. So 3 jumps of 5. So if I'm going to erase this, can you show me 3 jumps of 4? Feel free to count underneath if you want. So it's going to be 4 long. Okay, how many jumps do you have?
4.
Okay, read this number sentence.
3 times 4.
Read this.
3 jumps of 4.
And what do you have?
4 jumps of 3.
Right, so you're showing me the commutative, which is fine. However, 4 times 3 is a completely different model. Do you see that? Okay, so let's try that again. Can you do 3 jumps of 4, please? Thank you so much for working so hard on this. It took us 2 times, but we got it, and you kept working with it, and I really appreciate you staying with it. Okay, so now read me this number sentence.
3 times 4.
And this says 4. And then, if we look at our number line, how many jumps do you have?
3 jumps and 4 long.
4 long. And is that what our number sentence says? Awesome. Thank you for working so hard through that. That didn't take long to get through, but now do you understand it? Can I give you another stick and you do this again just to make sure we understand how to represent it correctly? All right, show me 3 times 10. And this looks perfect. So go ahead and show me 3 times 10.